Hi, Algebra 1. In Unit 3, Lesson 7 here, we're going to be looking at the correlation coefficient. It's going to be a number that we use to evaluate how good of a fit a line of best fit is to the data. Here we go. We are going to skip ahead in your notebook to activity 7.3, and these are some notes that you're going to have to write down. First thing is that we're going to use a number called R, and that's going to be the correlation coefficient is what we call it. And it's how we measure the strength of a linear relationship. The first thing that you need to know is point 1 right here, that the sign of R is the same as the sign of the slope of the line of best fit. So that means in this example right here, this line of best fit has a positive slope. Our value for R, the correlation coefficient, is positive. Over here, the line has a negative slope, and the value of the correlation coefficient is negative. This value for R is not the slope, but its sign, whether it's positive or negative, will be the same as whether the slope is positive or the slope is negative. The next thing you need to know is point 2 right here. The values of R go from -1 to 1. Inclusive means that we can have an R of 1 and we can have an R of -1. And then number 3, the closer R is to 1 or -1, the stronger the linear relationship is between the variables, which just means that if, for example, R is exactly 1, then your data is in a perfectly straight line. If R is a pretty high number close to 1, like 0.8, then your data is pretty close to that line of best fit. But as R gets smaller, like 0.3, that data is going to be more spread out. The exact same thing happens over here in those negative values. The last point, number 4 here, says that the closer R is to 0, the weaker the linear relationship is, which just means that as your value of R gets closer and closer to 0, the more spread out your data is going to be. And when you see when R is exactly 0, that just means that the data is so spread out, there is no relationship between these variables that you're measuring. Your line of best fit would just be a horizontal line there. So in the rest of activity 7.3, now that you've taken your notes, you can complete the rest of it with a partner, or you can complete it on your own. And the instructions are going to be slightly different depending on what you do. Now, what we're going to have is a whole bunch of scatter plots and a whole bunch of values for the correlation coefficient. And you're going to be matching which correlation coefficient goes with which scatter plot. If you choose to do this with a partner, take turns matching your correlation coefficients to the scatter plot and explain to your partner how you know it's a match. When you've finished, you're going to check your work by answering the questions here in Edpuzzle, and then make corrections as you need in your workbook so that you have good examples to look back at. If you're going to complete this on your own, you will be matching each scatter plot to a correlation coefficient in your workbook. Do it all in your workbook first. Then when you finish, check your work by answering the questions here in Edpuzzle and make corrections as you need as you go. In A, this has a correlation coefficient of exactly 1 because the lines make a perfectly straight line and it has a positive slope. For B, the R value needs to be positive again because that has a positive slope. And looking ahead to the other options, this one has the points that are closest to the line. Looking at the other graphs, and so that one's going to be closest to 1, so that's going to be 0.9. Both C and D are going to have negative correlation coefficients because both of them have a negative slope. C has points that are a lot closer to the line, so this is going to be a lot closer to -1, so negative 0.95 fits good here, and this one just has points that are further away from the line, so negative 0.74 fits there. Looking at graph E, this is going to have a positive correlation coefficient, and looking at our options left, 0.65 matches this one better. It's further away from the line than our graph with 0.9, but it's going to be closer, the points are closer to the line than the next graph coming up. In F, the points are in a perfectly straight line with a negative slope, so that's going to be a correlation coefficient of -1. In G, this is really close to having a correlation coefficient of 0. I do see a slight negative slope there, so that negative 0.06 correlation coefficient matches that one. In H, we have a positive slope, and the points are more spread out than any of the other graphs we saw with a positive slope, and so that's going to be a correlation coefficient of 0.48. Looking at the end of the lesson in your lesson summary, it has some good examples for correlation coefficient. Right here, these graphs give you examples of what the R values would be that match those. One thing to keep in mind is that you will not have to calculate the correlation coefficient. We are going to be using Desmos to get your correlation coefficient for you. You have to be able to interpret what it means.